So hello everyone, now in this video I am going to start exercise 9.3, the chapter differential equation from the book of Aggarwal. For the others chapter, please visit our website. The link is in the description box. So here the first problem, sum number 1. From the differential equation of the family of straight line y equal to mx, where m is arbitrary constant. Okay. So you have to form the differential equation of the family of the straight line y equal to mx. So suppose this one is equation. So now differentiate with respect to x. So it will be here dy dx and that one equal to m, because the ddx of x equal to 1. Now let as 2 this one. So eliminating m from 1 and 2, you can write down y equal to x into dy dx, because m is the value of dy dx. Okay, so that is your answer. Now next one, number 2. Find the differential equation of the family of a straight line y equal to mx plus c, where m, c are arbitrary constant. Again similar kind of problem. So find out dy dx, that one equal to m. Okay, now again differentiate this one. So d square y dx square equal to 0. Okay, so that is your answer. Now next, third one. Form the differential equation of the family of concentric circle. Here the equation x square plus y square equal to r square, where r is arbitrary constant. Okay, so differentiate with respect to x. This one equal to 2x plus 2y dy dx, that one equal to 0. Okay, so if 2 will be common, so x plus y dy dx equal to 0, and that is your equation. Now next one, number 4. In number 4, form the differential equation. Okay, form the differential equation not containing the arbitrary constant and satisfied the following equation. So here the first problem, sum number 4.1, y equal to, you have a x to the power cube. A is the arbitrary constant. So differentiate with respect to x, dy dx equal to 3ax square. Okay, dy dx equal to 3ax square. Now on dividing this equation by equation number 1, okay, if you divide, suppose this one here equation number 1, this one here equation number 2, so divide equation number 2 by equation number 1, then you will get here 1 by y dy dx, and this one equal to here 3ax square by ax cube, so that one equal to 3 by x. Okay, now cross multiply, so x dy dx equal to 3y, x dy dx equal to 3y, that is your answer, because here you have to form the differential equation not containing the arbitrary constant. Okay, that means a not will be there. So in this equation x dy dx equal to 3y, there is no a. Okay, now next one, number 2. X square minus y square equal to here a square. Okay, so now differentiate with respect to x, 2x minus 2y dy dx, that one equal to 0. So if you common 2, it will be here x minus y dy dx, that one equal to 0. Okay, x minus y dy dx, that one equal to 0. So that is your answer. Now the third one here, y equal to c sine inverse x, where c is the arbitrary constant. So here dy dx equal to c by root over 1 minus x square, because derivative of sine inverse x 1 minus x square. So let this one as 1 and this one as 2. So now from 2, as here you have dy dx. Now from equation number 1, here the value of c equal to y by sine inverse x. So let's put down the value in equation number 2. So here y and this one here sine inverse x root over 1 minus x square. Okay, so that is your answer. Next, number 4, y square equal to 4ax. So here differentiate with respect to x to y dy dx, and this one equal to here 4a. To cancel out this one, so here y dy dx equal to 2a. Okay, y dy dx equal to 2a. Here you have y square equal to 4ax, that means here y square by x equal to 4a. Okay, then 2a equal to y square by 2x, that one equal to 2a. Now just put down the value here, so y dy dx in the place of 2a, y square by 2x, so y cancel out, so here 2x dy dx equal to y. Okay, so that is your answer. Now next, sum number 5. 5.1, y equal to e to the power mx, where m is the arbitrary constant. Here find the differential equation by eliminating the arbitrary constant and satisfied by the following equation. Okay, that means again similar kind of problem. So here dy dx equal to e to the power mx into m, that is the formula. So now in the place of e to the power mx you can write down y, so it will be my. So dy dx, okay, dy dx equal to my. So now let this one as equation number 2 and first one is equation number 1. So from 1, if you take log in both sides, so it will be here log y and this one here log e to the power mx. Okay, that means here mx equal to log e and this one here log y. So we can write down here log y equal to mx. Okay, that means here m equal to 1 by x log y. Now replace the value here, y into 1 by x log y. Okay, that means here dy dx equal to y by x log y, or you can also write down x dy dx equal to y log y. That is your equation. Next one, number 2. In 5.2 here y equal to k e to the power tan inverse x. Okay, where k is the arbitrary constant. So as here you have y equal to k e to the power tan inverse x. So now differentiate with respect to x, dy dx equal to k, then e to the power tan inverse x, derivative of tan inverse x 1 by 1 plus x square. So that means here 1 plus x square into dy dx, it's k e to the power tan inverse x, and that one equal to y. So that is your answer, 1 plus x square dy dx equal to y. Now sum number 3, sum number 5.3. 5.3 here you have y equal to, let's write it down, y equal to tan inverse x plus c e to the power, okay, c e to the power minus tan inverse x, where c is the arbitrary constant. Okay, so here we can write down this one here tan inverse, so dy dx, so first derivative of this one dy dx 1 by 1 plus x square plus c e to the power minus tan inverse x, okay, and it will be here minus 1 by x square, okay, minus 1 by x square. So now here 1 by 1 plus x square is the common, so 1 plus, or just write down this one as negative, so 1 minus c into e to the power minus tan inverse x. So here 1 plus x square dy dx equal to 1 minus c to the e to the power minus tan inverse x. Okay. So now in the place of c e to the power minus tan inverse x, we can write down y minus tan inverse x from the first equation. Okay. So here 1 minus, it will be here y minus tan inverse x. That means 1 plus, sorry, 1, it will be 1 minus y plus tan inverse x. That is your final answer. Now next one, sum number 6. Here the first one, x square plus y minus b whole square equal to 1. B is arbitrary constant. Okay. So first here you have to differentiate this one. So it will be 2x plus 2 into y minus b. Then again differentiate this one. It will be here dy dx, and that one equal to 0. Clear? Okay. So now you can write down here 2 into y minus b dy dx equal to here minus 2x. Now sorry, now 2 will be cancelled out. So y minus b, then dy dx equal to minus x. Okay. And next one, y minus b equal to minus x by dy dx. So you can replace the value in the first equation. So x square plus, in the place of y minus b, we can write down minus x whole square means y square, and this one here dy dx whole square, and that one equal to 1. Okay. If x square is common, it will be 1 plus 1 by dy dx whole square, that one equal to 1. So x square equal to here dy dx whole square plus 1 equal to dy dx whole square. Okay. So that is your final equation. Next, number 2, x minus a whole square, sorry, it will be minus y square equal to 1, where a is the arbitrary constant. So first differentiate it. So 2 into x minus a, then minus 2y dy dx equal to 0. That means x minus a minus y dy dx equal to 0, or you can write down x minus a equal to y dy dx. So in the place of x minus a from the first equation, we can write down y square, then dy dx whole square, then minus y square, that one equal to 1, and that is your equation. Next, number 3. In number 3, x square plus y square equal to ax cube. X square means 2x, y square 2y dy dx, and this one here 3ax square. Okay. It's equation number 2, and this one here equation number 1. So 2x plus 2y dy dx, and in the place of here, as in the first equation, you have ax cube equal to x square plus y square. So now you have 3a square. Okay. So we can write down this one here. Suppose if you divide the first equation by x, so this one equal to here ax square. Okay. So in the place of x square, we can write down x square plus y square by x. Is it clear? Okay. So now here multiply with x, so 2x square 2xy dy dx, that one equal to 3x square plus 3y square. Okay. So finally you have here 2xy dy dx equal to x square plus 3y square as your final answer. Now next one here, sum number 7. So here in sum number 7, x by a plus y by b equal to 1, where a and b arbitrary constant. Now the derivative of x by a, it's 1 by a, this one here 1 by b, and dy dx equal to 0. So we can write down here dy dx equal to here minus b by a. Okay, now again differentiate both sides, so it will be here d square y dx square, that one equal to 0, and that is your answer. Now next one, sum number 8. 8, the first one, y square equal to 4a into x minus b, where a and b are the arbitrary constant. So derivative of this one, 2y dy dx, here 4a, and x minus b, here the derivative is 1 minus 0, that means 1. So now 2 cancel out with this one, okay, or we can write down also, so one thing, just here 2y equal to dy dx, okay, and that one equal to 4a. So again derivative this one, so if you derivative this one, first one will be here 2, and here y d square y dx square plus here dy dx into again dy dx, or we can write down dy dx whole square. Clear? Dy dx whole square, and the derivative of 4a, that one equal to 0. So here your final answer, y d square y dx square plus dy dx whole square, then 0 by 2, that one equal to 0. It's very easy. Okay, now next one, sum number 8-2 is here 8-2. Sum number 8-2, you have y minus b whole square equal to 4 into x minus a. Okay, 4 into x minus a. So here 2 into y minus b, then dy dx, and this one here only 4. Okay, the derivative of y minus b whole square is 2 into y minus b dy dx, and that one equal to only 4. So now again differentiate this one, so it will be here y minus b, then here d square y dx square, and derivative sorry, you have to apply here the uv formula, so y minus b d square y dx square plus here dy dx, and again dy dx, this one equal to 0. So we can write down here y minus b, then here d square y dx square plus dy dx whole square equal to 0. Okay, now you have to eliminate this b, so as here y minus b, okay, y minus b equal to, you know that 2 by this one from the second line. From this line you can easily find out the value of y minus b. So here y minus b equal to 2 by dy dx into d square y dx square plus dy dx whole square equal to 0. So your final answer, 2 d square y dx square plus this one here dy dx whole cube. Whenever you multiply dy dx in both, that one equal to 0. So that is your answer. Now the last one, sum number 8-3. So guys, if you like my video, please share this video and please subscribe my channel. So here you have y square equal to a b square minus x square. So here 2y dy dx, here a, and this one here minus 2x. Okay, so that means here y dy dx equal to minus ax, y dy dx equal to minus a. Now again derivative this one, so y d square y dx square plus here dy dx whole square, and that one equal to minus a. Now from this line here minus a equal to, we can write down y by x dy dx. Okay, so let's replace the value here, so it's minus a means here y by x dy dx. Okay, y by x dy dx. So here your final answer here, y d square y dx square plus dy dx whole square, then minus y by x dy dx, that one equal to 0. Now if you multiply this one with x, so xy d square y dx square plus x dy dx whole square minus y dy dx equal to 0, that is your final answer.